I have the N2 set up to measure amperage and voltage, and I'm going to use this power test here to calculate the resistance of this circuit. Why I'm doing that is I want to test this stator, and how I'm going to do it is I need to measure the milliohm reading across each one of these phases here. So it would be 6 tests altogether. I'm only going to demonstrate one, but that way it'll make sense. But that's what we're going to do, and I'm going to explain to you how I'm going to do it without a milliohm meter. I have a volt lead set up to the positive lead out of my power supply. I have the amp lead here as the ground side of my circuit. And then I have the common ran over to the tip of my test light. And then the circuit's grounded through the test light to limit current back to the ground on the power supply that you can't see. It's behind my phone there. What I'm going to do is I'm going to run power into C, and it's going to come out of A, go through the test light, or through the meter, through the test light, and back to ground. And I'm going to measure the voltage drop between C and A, and that's all going to show up on this meter, and it's automatically going to calculate based on the amperage and the voltage drop. It's going to calculate the ohm readings, or the resistance. There we've got our 15 volts. I've got the power supply cranked because voltage is pressure, and I want a reasonable amount of pressure going through this stator. That's why I have everything switched on the ground side as well, is because if I put the current limiting resistor on the feed side, I'm going to have low voltage and high current. What I want is high voltage, high current, or reasonably high voltage. If you don't want to run 40 volts through this, but 15 is plenty okay, especially at 200 milliamps. So by putting 15 volts through the stator, through the test light, and back to the unit, I can effectively measure the voltage drop across the stator windings and calculate the milliohm reading. So now I have it hooked up. There's power going through C, ground through A, through the meter, through the test light, back to the power supply. And I'm getting 245 milliamps, 69 millivolts of drop, and I'm calculating 283 milliohms. Now that's not accurate because I have resistance in my test leads, and I'll show you that here. Even if I just short my test leads right together, I've still got 66, 70 milliohms. So that's the effective resistance of my test leads. And since I have C powered here, I want to check A and B. So I'm going to move my ground side from A to B and verify that my milliohm reading is very, very similar. Now, if I was really testing this unit, I would take 6 measurements. I would measure with the feed on C, and then the ground side on B, and then the ground side on A, write those 2 measurements down, and then I'd move my feed over to A, ground these 2, measure those, and then I'd move it to B, and then ground those and measure those. So I'd have 6 readings, and hopefully 6 identical milliohm readings. If I do, it's safe to assume either every circuit's shorted on this stator, or the stator's in good shape. And obviously it makes more sense that the stator would be in good shape, not every single circuit would be shorted. Here I'm going to move my power supply to B, and now we're testing B to A through the meter, through the light, and we're at 285 milliohms. And I'm going to move this over and check from B to C, and we're also really, really close. You know, a good rule of thumb is 5 to 10% variance is, you know, reasonably okay. Anything over that, you know, you probably have an issue. Move that over to A. Again, we're at 285 milliohms. Move it over to C. 285 milliohms. Or 283 on that one. That circuit might be getting hot. You know, as they heat up, the resistance will change a little bit. So if you wanted to get super accurate and try to calculate the exact milliohm rating, you would have to minus your, you know, whatever the compensation for your leads is. So like in this case, be near 60 milliohms, I'd minus that from that to determine my milliohm rating. So this is a really, you know, low budget way to test a stator or any three-phase circuitry. You know, it's not 100% foolproof, but you know, it's also not, you know, a really expensive milliohm meter, and this thing's capable of being reasonably accurate.